Alright guys, let's look at this problem. Let's look at this chemistry 102 LASU past questions. So this one says the IUPAC name of the compound above, this compound, that's what they are referring to, is A 1-hydroxyl 4-benzene, B 4-ethyl 1-hydroxybenzene, C p hydroxyl phenol, D p-ethyl phenol. Now this question is testing our understanding on the nomenclature of aromatic compound, that's the benzene, when we are talking of the disubstituted, that is when we have a benzene ring and one carbon of the benzene ring is attached to a group and another carbon is attached to another group. So which, and that's what disubstituted. So whenever we have a case of disubstituted, we use this man here. We use Ortho. We use Ortho meta para, or basically Ortho can be written as O, meta is M, and para is P, just to state that this is the relationship between the two substituents of that compound. So Ortho is that when we have the substituent with the highest priority at, so that the substituent with the highest priority will be at carbon 1, so it will be 1, then and the substituent with, like, the next substituent must be at carbon 2. Hence Ortho is what, a 1-2 relationship between the two substituents in a disubstituted benzene ring. So now the meta is, now if the substituent with the highest priority is at carbon 1, it will always be at carbon 1. That's where we'll start counting from. And the other substituent is at carbon 3 when we count from that carbon 1. Hence it is what, meta relationship. Now the next one will now be 1, 4. So now let's look at this compound and check out how to write the IUPAC nomenclature and check out the correct answer here. Now if you have this man here, it will be what? Now if you check out, this is an ethyl group here. This is an ethyl group. And this is hydroxyl group. Now hydroxyl group and ethyl group, which one has the highest priorities? Is hydroxyl group. Hence this will be at carbon 1. And if you are counting it from here, it will be what? 1, 2, 3, 4. That is the carbon, the second substituent is at carbon 4. So the relationship between the both of them is what? 1, 4 relationship. And that 1, 4 is what? Para, which is P. So from here you can see that these two options are not correct. So our option should be between this C and option D. Now if you understand better, you will have to know that whenever you see OH attached to a benzene ring, it is called phenol. OH attached to a benzene ring is called phenol. Hence what they are just trying to tell us is that the parent name will not be benzene again, it will be what? Phenol. But we will still take this as a substituent to get its relationship with the other substituent. Hence we'll be having something of, so instead of writing 4-ethyl, telling us that when we are considering this man here, the ethyl is at carbon 4 from it, we will just be writing p-ethyl phenol. That's just the concept here, because the ethyl is at carbon 4 from this OH. Hence the relationship is para, and it will what? P-ethyl phenol, making option D the correct answer. Had it been the ethyl is here, it will be what? It will be M-ethyl phenol. Now had it been OH is not there, had it been is something of CH3. When we have CH3 attached to a benzene ring, it is known as what? Toluene. So in that case, let's say we have CH3, it will now be what? P-ethyl toluene. So that's just the basic idea there. Had it been we have OH, let's say we have the ethyl group at the carbon 2 here, and we have the CH3 here. So, and we already know that when CH3 is attached to a benzene ring, it is toluene. So you just get the other substituent. You look at the other substituent so that we can get the relationship between the both of them, and that is Ortho. So that will be what? O ethyl toluene. So that's just the concept, the O ethyl toluene. So that's like Ortho ethyl, because the CH3 making it toluene is at this carbon, and that's where we'll start counting from, and the ethyl is adjacent to it. Now another question they could ask is that for Ortho, the relationship between the two groups, that is the two substituents, is what? They are adjacent to one another. That's just it. Now let's look at this other question here. Now this question says how many benzylic hydrogen are present in phenol. Now to answer this question, let's draw a phenol. Let's draw a phenol compound. Let's put our OH here. Yeah. So this is more like a phenol compound, and I told you earlier that phenol is when we have OH to a benzene ring, but phenyl is when we have phenyl is when a benzene ring is acting as a substituent to a aliphatic chain, when it is attached to an aliphatic chain, and the aliphatic chain has higher number of carbon atoms than this benzene, hence the benzene will be called phenyl. But when we just have a benzene ring and we have OH attached to it, there are some common benzene structure you have to know, and when all these things are attached to them, and even it is NH2, it is called aniline. If it is OCH3, that will be called anisole. So we have to know all these things when it is OCH3 attached to it. So now to this question, benzylic hydrogen. Now we have benzylic carbon and benzylic hydrogen, but this past question is talking about benzylic hydrogen. Now for benzylic carbon, it is the number of, let's say, is the number of carbon atoms directly attached to the ring. You understand? That's just the concept there. Let's say we have this ring like this, the benzene ring, and we have CH3. So the number of carbon atoms attached directly to this ring is this carbon here, and that is the benzylic carbon is 1. And the benzylic hydrogen is the number of hydrogen atoms, that is the 9 hydrogen atoms that is attached to this benzylic carbon, and that is 3. This is for toluene. Now to this man here, we do not have carbon atom attached to this benzene ring. So this is where most people make the mistake. We do not have carbon atom attached to this benzene ring, hence we cannot have benzylic carbon or benzylic hydrogen. Since we do not have benzylic carbon, we cannot have benzylic hydrogen, hence the correct answer is 0, because it's very, very, very tricky. Some people will pick one because of this hydrogen. This man here is attached directly to this oxygen, not hydrogen. You understand? So making it not benzylic hydrogen. We must have benzylic carbon for us to have what? Benzylic hydrogen. And benzylic carbon is those carbon that attach directly to what? Benzene ring. Now to this last question. This question says the maximum number of isomers of a compound with 2 stereo centers is A1, B2, and C4, D8. Now to get, this is a very straightforward question in the last question. So when we have maximum number of isomers of a compound, for that compound, we just have to know this formula. It does not stress us. So just note 2 raised to power n. You understand? For you to get the number of isomers for a compound that has stereo centers. Now this n is the what? Number of stereo centers, and this question says 2 stereo centers. Let's say what? 2 raised to power 2. So from here there we have 2 raised to power 2, and that is 4 isomers, making option C the correct answer. So that's all about this video, as we've solved the three some tricky questions. Note this under the benzylic stuff, and this man here under the disubstituted aromatic compound. And know your ortho, meta, para, know the relationship, and know some common name of aromatic compound when we have OH attached to the ring, when we have CH3, when we have OCH3. And see you in the next video, and subscribe for more.